Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have two guests, Chloe and Matteo. Hi, Chloe and Matteo. Tell us a few words about yourself and about the tool you want to show us.
Hi, I'm Matteo. I'm originally from Italy, and I'm the co-founder of Dozer, which is an open source tool and a startup as well, based out of Singapore, to solve a simple problem. You have data in many companies have data in their own backend system, which can be a relational database like Postgres, can be analytical stores or data lakes like Snowflake and ClickHouse and Databricks and S3 files as well. And in many situations, you need to take this data, combine it together, and create APIs very efficiently so that this data can be integrated with customer-facing application. You can think, for example, about, because I'm actually coming from a financial services background, so you can think about your banking application. When you just log in, you need to have access to tons of different information coming from multiple systems. And this is a complex work to orchestrate. And that's what Dozer solves. Dozer is fully open source. And that's our brief intro. And I'm happy to hand over to Chloe, which can go straight to the demo.
All right, thank you so much for an overview, Matteo. So I'll be sharing my screen. Hi, I'm Chloe Kim. I'm also part of Dozer, and I'm a software engineer in Dozer, taking care of Dozer Core, Dozer Cloud, so any features that we're supporting as a Dozer as a product. So let's dive into a Dozer in action. So what we can start with is basically installing Dozer. So we can do Dozer tab get Dozer, and brew install Dozer. So this will do the job. It won't take.
For those who are not on Mac, what do they do? Like me, for example.
Yeah. So in other architecture, we also do have a documentation on how to install in our getdozer.io. So you can follow Get Started over there, and our latest version is 0.1.27. So we can see that it is getting the right information. And to verify on your successful installation, what you can run is Dozer help. So by doing this, it will show you all the list of commands that you can run using our latest version. And Dozer init, which initialize an app using a template, sounds like a start to me. So I'll do Dozer init. So it will require some input from you as a user, but I'll be taking default to see what's going to be the effect of this command. So after doing this, what it creates is basically a dozer-config in your workspace. So this, if you open this file up, it will be already populated with some template on it, but template is basically for the guidance for you to provide the right information in the right format for various connectors that we support as a source. For example, Postgres, Snowflake, Ethereum, or local object store, Debezium, Kafka, and so forth. But today, what we're going to do is we're going to be starting clean so that we can figure out what's going to be the bare minimum for us to provide to get started with Dozer. So there's 3 parts that we need to provide to get started with Dozer. First one is connections. Second is sources, and lastly, endpoints. Starting with connections, connections are basically the information that we need on how to connect to your database. So today's sample data app, what we're going to do is we're going to be based on a very simple IoT device that captures a temperature of a room every second. And if the temperature goes above too high, then we basically get an alert using Dozer. So the key point here would be on a demonstration of utilizing our Python client library, which works with Dozer client that we're going to be running soon. And this Python client library is basically a wrapper on top of Dozer gRPC API. So Python client library is going to be acting as a data source, which pumping out data as a gRPC. So here we're going to be configuring for gRPC, like I said. And for gRPC connection to be valid, what we need is a input schemas. So for schema, let me show you. So this is a simple JSON that we're going to be using as an input schema. It will contain very simple information about events table, which is having 3 different fields: ID, temperature, and time. So we're going to be referring to that in our config by path. And lastly, what we also need is a port. How are you going to connecting back to Dozer client using that data that we're pumping out of Python client library? We're going to be working on a single port, let's say 7001. And I'm going to be naming this connection as ingest, because Dozer client is going to be ingesting that later, and we can utilize this as a reference in other sections as well. And moving on to sources. Sources are the information that we need for what kind of table that we need to look up for to get the data. So in this case, we're going to be utilizing the events table. So the table name that we're going to be referring to is events. And the connection that we're going to be utilizing to get this is the ingest. And we also can specify on what kind of columns that we actually get out of the table. But if you leave it as blank, it will get all the columns by default. And also I'll name this source as events too. And lastly, we are here for endpoints. So endpoints are basically the end result that you want out of Dozer. So it's going to be an API, it's going to be an endpoint. And first API that we want to create is basically representing all the data that we're getting out of events table. So I'm going to be utilizing events table too. And the path of this API, I'm just going to be following the table name for simplicity. And you can also specify on some indexes like primary key, but I'll be leaving it as blank for this. And I'll name this endpoint as events too. So this is basically the bare minimum that you need to run the Dozer. So to run Dozer, all you got to do is just Dozer. But in case you have any custom config name, you can say like custom config.yaml, but we're using the Dozer YAML that we got from the Dozer init. So I'll just run the Dozer. So you can see that what kind of version that we're running on and all the information. So it is working fine, but I want to revamp a bit more on our config. So as I said in the introduction, what we want to do is we want to get an alert out of this. So in case is there any temperature that is going above a certain level, we want to get alert in any form. So to do that, we can introduce another section called SQL. So in this SQL section, what we can do is we can do some real-time data transformation using SQL query. So what I'm going to be doing is I'm going to be selecting ID column, temperature column from events table. And we're going to be having a where clause saying some filters on temperature that is greater than 23.0. So in case of any temperature that is going above 23, we're just going to be getting that as alerts. And we're exporting this results using into clause. So I'll be naming this as alerts. And utilizing this, we can also create another endpoint. I'll be getting data from this temporary table called alerts, and I'll be following the convention.
I am not sure I completely understood what the SQL part is doing here.
SQL part, so it basically do another filtering, real-time data transformation as a temporary view on top of your data. So it is running with the filter as we running the client itself.
So we're receiving data, all the data in the events, and then there is an extra step, a filtering step that takes an event and filters everything that is, keeps everything that is above 23, right? And then at the end we have kind of two tables, right? One with all the events and the other with just alerts.
Amazing. Yes.
One thing I want to add here, actually, because you brought it up, Dozer actually embeds a full streaming SQL engine, actually. So we built up a SQL engine that takes all the information, takes all the data in real time, and executes the query in real time. So here you can use filters, you can use aggregation, you can do pretty complex query to shape the data in the data the way you want it, and everything is processed in real time in a streaming fashion.
So we're ready with revamping with real-time data transformation in the SQL section. So we're ready to run Dozer again. So if you look through the logs, we can see we're running on the latest version. And for Dozer, it by default presents your endpoints in two different types of APIs, REST and gRPC in their default parts. And you can see that it is also getting the right input schema, like we specify in the JSON file. If you go to the bottom, you can see the server is already running, but our pipeline is not getting any data yet. So here is where the Python client library comes in. So we're going to be pushing out some data out of Python client library, reading CSV, and it will be presenting data as a gRPC format. So here's the main.py that we're going to be tackling to cover the Python client library sample. So here we are importing pydozer, which is our Python client library, basically a simple wrapper on top of gRPC API. It consists of two different submodules, ingest and API. In today's sample, we're going to be covering mostly IngestClient, but we do also have API client, which will be ingesting data like we're doing in the Dozer client, but we'll be tackling this later on. So to initialize IngestClient, we need to specify on what kind of port, what kind of URL that we're going to be talking to the Dozer client. And we already specify in the config saying that we're going to be talking on 7001. We're going to be following exactly the same to initialize it. And in this main run function, like I described before, it's going to be reading CSV line by line. And the CSV is looking like this. It contains the timestamp, device ID, some sort of data, but we're only focusing on temperature for today. And what it basically do is it reads each row and get the data that we want out of it. And we basically call a send message function. In the send message function, we create ingest request. Ingest request contains two different important information. One is what kind of schema that we're targeting for to ingest this data back, and how the record should be structured. So in this case, like we specify in the config saying that we're getting it from events table, we are referring to that here as a schema. And each record is going to be consisting of three different values, which is corresponding to three different fields in the table, device ID, temperature value, and the timestamp that we're getting in. After initializing this request object, we are utilizing the client that we initialized earlier to call ingest function. There's 4 different types of ingest function that you can utilize. The one that we're using here is with the common format. You can specify any format that you want in terms of the records that you're going to be ingesting. But in terms of you want to utilizing with streaming, you can also use this. And we also support the data frame from pandas and with the arrow format as well. So this is basically the main.py that we're going to be running. So here, as you can see, we're not getting much of a data in the pipeline. But once we started pumping out the data out of Python client library, we are ingesting the data simultaneously. So this data will be having an output of events and alerts. So let's check on the data in the Postman. Is it good enough? Okay, so let's check on the data. So we're running on the default part, like I already said, and we are utilizing server reflection to get any of the data that we're running as a gRPC API. We do have 2 different endpoints, events and alerts. So if you query an event, we're getting all the information that we're pumping out of our client library, like you just saw. And same information will be available in REST format as well. So we're running on the 8080, which is a default port. And /events was the path that we specify for that endpoint. If you call the GET request, we're getting exactly the same query results. And on top of it, each endpoint, we support /query at the end with the post request. So what it basically do is it does a real-time filtering, like limiting the number of results that you're getting, which is useful for the pagination, and some filtering on top of certain columns, like say, we're just filtering on the temperature column that is greater than 22.4. And we also support order by, and we're getting it the data as ascending order. So let's see. So we're expecting just 4 different records, and we're getting 4. And it needs to be in ascending order, but it needs to be greater than 22.4. So it's just getting 22.5, 5, and 6. So you can filter on your result real time like this. And for the alerts endpoint, like we specify in the SQL query, we're expecting certain part of the data that we have pumped in. So if you look into the past history of the data, there's only one temperature that is going above of 23. So we're expecting just one record to be there in, as a result of alerts endpoint. What we also support is a open API config. So any endpoint that you specify in the config /OAPI with the post request, you're able to get a handy config that you can plug and play for the open API. So, so we can see the Python client library and Dozer client is going back and forth really well. But here we need something more. We want to get some alerts in a tangible format. So without saying an alert in a console, I want to get an SMS message. So what we're going to do is we're going to be running another Python file that has been integrated with Twilio. So we're utilizing our Twilio account with SID and token. We're going to be reading through a log reader. So this is basically the function that we support as a Lambda function, or we so-called change data function, CDF. So it's going to be reading our log that is coming out of Dozer, and it filters on certain endpoints. We only want alert log. And while the log is coming in, we go through every data points that we're getting. As a new record, we basically say an alert and send out the message. So let's see what's going to happen when we run this. So I'm going to be running Dozer. None of the data has been pumped in yet. And meanwhile, I'll be running reader. And reader is reading the log out of Dozer, but there's no new log coming in yet. So it's ingesting nothing. And if I run main.py at the same time, as you can see, it is ingesting, and our reader is also ingesting at the same time, and see whether there is any record that is going above 23.0 degree. So let's give it a minute before we actually see the alerts.
And I have a question. So from what I understood, when you stop Dozer, it removed all the data, right? So in this particular case, the data is kind of lost, right? Or what exactly happened?
Let me take the question. So Dozer, now we are running Dozer as a single process, and that's the case. But Dozer can be run as 2 different processes. So one process is basically testing the data and processing, and the other process is the caching, is basically the caching plus the API. So if you run those 2 separately, you can stop the processing of the data, but your API and the cache are still alive.
Okay, so we're running Dozer client like we did before. We're running reader, meanwhile, to read the log, to give them some Lambda functionality as a change data function. And we're going to be pumping in data. And if there is any data that is qualified for our SQL real-time data transformation, it will be read by our change data function and to be able to give out an alert. So give it a few seconds. So once it reached 23 degree, it gives us an alert and give us the message ID. And this is my iMessage, and ta-da, we're getting the iMessage saying that the room temperature is going certain level and it's getting hot. So this is basically a end-to-end connectivity from Dozer client, Dozer Python client library. And lastly, we can also visualize this in a nicer format. So this is another client library that we also support, which is React. So we are getting the real-time data from it and representing that as a graph. So this is basically end of what we prepared for today as a demo. And in case you guys need any of the source code that we covered today, every part is available in our GitHub repository. So you can check it out. So to conclude, Dozer supports a few different connectors, Postgres, Ethereum, Snowflake, Debezium, Kafka, local object store, and it will keep evolving as we are expanding our capabilities and also what you need as a Dozer user. So it will be good if you can visit our website and start us on GitHub and stay connected by joining our Discord channel. We're quite active on it, so ask us any questions. And yeah, this is everything that we prepared for today. Thank you.
Please send us all the links and we will make sure to include them in the description.
Yes.
And thanks for the demo. As I understood, you right now have two readers. One Python reader, right? The one that uses gRPC to talk to Dozer. And what I see right now on the screen is another client, another reader, which uses JavaScript for reading,
Yes.
for talking to, like, it's a JavaScript client, and then I don't know, it probably uses Rust, right, to communicate with the Dozer server.
Correct.
Okay, that's pretty interesting, and it looks pretty cool. Okay, yeah, awesome demo. I have a few questions. How many
Sure.
people are working on this tool, on Dozer?
Currently, the company is about 10 people, actually. Well, it's 10 people, including us, two founders, and a couple of people that are not really active on development, actually. Like, but yeah, total about the company is about 10 people.
Mm-hmm. And if somebody, you probably, since you're an open source project, you probably have external contributors. So
Right.
how can somebody become an external contributor? How can somebody contribute to Dozer?
Okay, there are a few ways actually. One way is contributing on the core, where there is a lot of stuff going on. As I mentioned before, we have a full implementation of a streaming SQL engine. We have a full implementation of a caching layer that is based on LMDB. This is all open source, and this is all written in Rust, actually. So I can imagine for some contributors, it might be a steep learning curve, actually, to get into Rust maybe and get into the, some details of the core components. However, we're pretty active on GitHub with the issues, with the discussions there. But at the same time, we also have a Discord channel where all our developers are there answering questions and supporting people using Dozer. The other way for contributing and to getting started, easier to get started, is probably maybe through the samples. We have a Dozer samples repository where these samples are also stored. And, we are always thinking about new samples to build on, et cetera, et cetera. So those are the two ways to contribute. And if you go to our GitHub repo, there are a couple of open issues, actually. Some we also started experimenting with paid bounties, actually, so that we have different ways people can contribute.
Can you stop sharing your screen, please?
Sure.
Okay. And Do you have any advice for anyone who is watching this? And since there are two of you, maybe each of you can give a piece of advice.
Advice for, you're talking about Dozer related specifically, or?
Dozer, data engineering, life advice, any?
Okay. One advice that I have is that, and that is the reason why we started Dozer, is that, more and more companies are needing to use their data, leverage their data to put it in front of the people, integrated with mobile apps, web apps, etc., etc. And, when you start doing this, because I've seen it myself multiple times, you start bringing up a very complex infrastructure. So you start connecting to your databases, CDC, bringing up tools like the Debezium, bringing up tools like Kafka and key value stores like Redis, Aerospike, build API layer, etc., etc. And sometimes, I would say very often, all this complexity is not really necessary given the volume of the data. And that's the rationale behind Dozer, where you have a very simple tool allowing you to take your data from the system and exposing as an API. So if you are running into this problem, I would say check out Dozer. Probably it can help you because it came from that particular experience. The other thing I want to say is that the world of data engineering is changing a lot recently. And, data engineering has been primarily dominated by Java and JVM-based tools. And now people started to realizing the value of using lower level languages like Rust, which that can be really helpful to squeeze as many cycles as possible from your CPU. So what would have required before a distributed system, maybe you can be done today with a single machine, with a multi-core machine, with a much more efficient language. So that's that thing I feel is changing, and I would advise people to look into this.
Look into Rust, right?
Yeah. Right.
All right. From my side, I would give more general advice per se. So it was a very honor for me to be part of this Dozer journey, but as a broader perspective, I am in open source community scene at the moment, right? So to maximize this opportunity, this journey is basically get involved in community, communicate a lot, converse a lot, reach out to people, ask for questions, like revital all the communities that we can run any source of information sharing. So I would love Dozer to be part of it. So yeah, I think that's basically the advice that I want to give to everybody who's watching this.
Be a part of open source, right?
Yeah.
Okay. Thanks you, both of you, for joining us today, for doing the demo, for telling us about Dozer, for giving the advice. Great demo, pleasure having you, and thanks everyone for watching our video.